Now let's look at logarithm equations. Now when solving a logarithm equation, it's necessary to check your answers back into the original equation because we may come up with some extraneous solutions. Here's some examples of what a logarithm equation may look like. It's one that contains a variable in a logarithmic expression. There could be a single logarithmic expression or several log expressions. To solve a log equation, and if it can be expressed in the form log of a single quantity equal to a constant, then all we do is convert it back to the exponential form like we did back in 4.2. Just convert it to its exponential form. Once we do that, we can solve it and things will work out beautifully. So we're looking to express it in this format. Well, I have log base 4 of x minus 7 in parentheses, close that off, plus 5 equal 15. I want to have it in the format of the log of a single quantity equal to a constant. So I want to get that on the other side, so I'll have the log standing alone on one side. So if I take the 5 and subtract it, I'll end up with 10. So I'm kind of isolating the logarithm expression here. Now that it's in this format, let's just convert it to b to the c equal to m, or m equal b to the c. It means the same thing. M is this part right here. This is our m. This is our b. This is our c. So when we convert it, it looks like x minus 7 equal 4 to the 10th power. Well, 4 to the 10th power is going to be a pretty large number, but we can still use our calculator to find it. Let's finish solving for x. X will be 4 to the 10th plus 7. And let's pull the calculator out and find out what 4 to the 10th plus 7 is going to be. 104.8583. 104.8583. So there's the exact value of the logarithm, the solution to that logarithm equation. Expressed it in this format, then converted it to its equivalent exponential form. Notice this one is already in the format of the log of some quantity equal to a constant. Log of some quantity equal to a constant. So let's do the converting, where this part is my m, this part is my c, but what's my b? What's my base b? It's understood to be e. Be careful. Let's convert it to m equal b to the c, so it'll be 3x plus 2 equal e to the 4th. B to the c will be e to the 4th. Solving it for x, we'll first subtract 2, e to the 4th minus 2, divide by 3, and there's our answer. E to the 4th minus 2 over 3. And they may ask for your answer in terms of the natural exponential. They may also ask you for your answer as a decimal approximation. So e to the 4th minus 2 over 3 would look like this. 17.533. So this is an answer using the natural exponential. This is an answer as a decimal approximation. Let's try to get this one in the desired format. Log base b of some quantity equal to c. Well, what I have here on the left are two logarithms. But from previous work that we've done, we can take these logarithms and combine them. Those two logarithms will combine since they're added with multiplication. It'll be log of x times x minus 3 equal 1. Notice by combining them, I have it in the desired format, log of some quantity equal to a constant. Once it's in that format, let's go ahead and convert it. So this whole thing is the m, this part is the c, and remember, if you have a log without a base, it's understood to be 10, and 10 will be our b. So let's convert it to m equal b to the c. X times x minus 3 equal 10 to the first power. What we end up with is a quadratic. Anytime you end up with a quadratic, it's going to always factor. X squared minus 3x minus 10 equals 0. And that's going to factor 5 times 2, negative 5, positive 2. And if I set each to 0, I get a 5 and I get a negative 2. Now, at the beginning, I said, oh, we've got to watch out. When solving logarithm equations, it's necessary to check your answers back into the original. The reason we want to do that is we want to make sure we don't end up taking the log of a negative number. And if I put this 1 million in place for x, I don't end up taking the log of a negative number. It checks. If I put 17.533 right here for x, I end up taking the log of a positive number. I'm okay. If I put a 5 in place for x, I end up having the log of 5 and the log of 2. That's okay. If I put a negative 2 in place for x, I've got a problem. I end up taking the log of a negative number, so I have to throw this one out. That's why we check our solutions, because we can't take the log of a negative number. Can't take the log of a negative number. That's why we have to check the solutions.